Enterprise integration patterns. These patterns generally deal with messaging and communication between multiple systems. The service layer pattern, a way to organize system logic in an application. It acts as an intermediary between the client and the domain model. The client in this case is either UI or an external service, while the domain contains system logic and data access. The service layer encapsulates the system operations, providing a simplified API for clients. The Data Transfer Object Pattern, or DTO, used to transfer data between layers of an application or between systems. DTOs are lightweight objects that don't typically contain any logic, but only hold data for transfer. DTOs can lead to redundancy if you have too many types that essentially contain the same information. Managing them can become cumbersome, especially in systems with numerous endpoints or layers. The Message Broker Pattern, a middleware component that handles exchanges and routing between applications or systems, allowing them to communicate in an asynchronous manner without being directly connected to each other. While it decouples systems, it can become a single point of failure. Heavy loads can also cause latency issues. The Message Queue Pattern, a way to hold messages sent between services or applications. It ensures that messages are processed asynchronously and guarantees that messages are not lost, even in case of service failure. It's helpful in situations where services need to process tasks in the background, or in cases where operations might be time-consuming or resource-intensive. Message queues can add complexity by introducing an additional layer for message processing. Also, if the queue becomes too large, or services fail to process messages in time, it can result in message backlog, leading to performance degradation. Enterprise Service Bus, or ESB, a central hub for routing, transforming, and handling messages between components. Start by defining an interface with a method for handling messages. Child classes will provide specific implementations. The ESB will keep a list of all services that need to be notified and a way for objects to register calls. When an object calls the ESB, asking it to send a message, the ESB will loop over all registered services and notify them. Use this pattern when you have a large, complex system that involves numerous applications or services that need to communicate in an integrated manner. ESBs can become overly complex and require significant overhead for setup and maintenance. They can also become performance bottlenecks and single points of failure in large distributed systems. The Aggregator pattern, used to gather messages or data from multiple sources and combine them into a single message or data structure. This is often used when you need to collect information from different services or systems and consolidate it into a unified response. The aggregator can become a performance bottleneck if the aggregation process is too complex or if it collects large amounts of data. It can also introduce tight coupling between the components that need to aggregate data. The Splitter pattern, the reverse of the aggregator pattern. It splits a single message into multiple smaller messages, which can then be processed independently. After processing, the results can be reassembled if needed. Use the splitter when you need to break down a large request into smaller, manageable parts for parallel processing. Splitters introduce complexity in how data is partitioned and later reassembled. If not handled properly, splitting and merging data can lead to inconsistency and hard-to-debug issues. The Content Filter pattern, used to filter out unwanted content from messages or data as they pass through a system. This can include sanitizing data, removing irrelevant information, or preventing issues such as security vulnerabilities or data corruption. Poorly designed filters may allow malicious data to slip through, or, conversely, overly restrictive filters can block legitimate data. Filters can add overhead in terms of processing time and complexity, especially if multiple layers of filtering are involved. The Message Translator pattern, used to convert messages from one format to another. This is typically required when different systems or services use different data formats. Functions like from.json or to.png would be examples of this pattern. Care must be taken to ensure accurate translation. If there are any design patterns you think we missed, let us know in the comments below. If you found this video helpful, please make sure to like, share, and subscribe so you stay up to date when we release new content. If you'd like to learn more about programming and game design, click on the link appearing on your screen now. or see the description below for ways you can help support this channel. Thanks, and take care.